Hi and welcome. In this video, we are going to see about maximize letter beauty question from March CookOff 2020. So what the question says is, chef's friend want to celebrate the special occasion of his birthday. So they are writing letters to him. Chef has received n letters. So in this particular test case, n value is nothing but 5. Okay. Next point is, initially for each valid I, he assigned a beauty bi to the letter from the is friend. So this elements is nothing but the beauty. Okay, after this what we got here is there are q queries. So q value is 5, so n value is 5 here, q value is 5, and the beauties are 2, -1, 2, -3 and 3. It is given that these values may even be negative for the letters that are not written well. Fine. So there are two types of queries. In the first query we will get q as the first character, then x and y as two integers. Okay, now we need to choose a L which will be less than or equal to x, okay, greater than or equal to 1, less than or equal to x, okay, and we need to choose a R which will be greater than or equal to y and less than or equal to the last n, okay, and x will be less than or equal to y always. So we need to choose a L at x or before x, and we need to choose a R at y or after y, such that if we add all the beauties between L and R range, if we add all the beauty values between L and R range, we get the maximum possible sum. Fine, I will explain you this with the help of an example. Now the second query is update query, u x comma v. Okay, so it says that chef re-evaluate the beauty of the letter from the xth fan. Fine, the new value will be v. So this is nothing but update in our array the beauty values. Okay, so let's just see the test cases, how it is working, what are the values, what are the answers, and what is this query, how to find the values of L and R such that we get the maximum possible sum for this particular test case. Let's begin. So if we see this particular case of q 3 and 5, x value is 3, okay, and y value is 5. In this case, what we need to do is we need to select L and R such that we get the maximum possible sum. Okay, so R cannot be anything else. R has to be this point only because there is no element after this, and L can be this point or L can be this point. Now if L is this point, that means we need to find the sum from 2 to 5. What is the sum? 3 and 3 get cancelled and the sum is 1. If L is this, then the sum we get is nothing but 3. So we will choose the one with the maximum sum and we will print it. So in this particular case, L value will be 1, R value will be 5, and we will print the maximum possible sum for this query, which is nothing but 3. Fine. In the second query we have 2 to 4. Now in the case of 2 to 4, we have possibilities for R also, correct, and we have possibilities for L also. Now let's see. So x value is 2 and y value is 4. Now R can be this element, correct, here L can be this element, and they can be equal also. So in this particular case, if x and y are equal, then this is nothing but how much? -2. Fine. And if we take L here and R to this position, then the sum will become 0. Fine. And if we take L here and R here, the sum will become 3. Okay, if we take L here and R here, then the sum will become 1. So what the L and R we should choose? We should choose the L this position and R this position to get the sum, maximum sum. This is nothing but 3. So for this also the value is 3. Fine. The U says that at the first position, that is x value first, update from 2 to 1. Fine. And then again some queries are given of 2 to 4 and 3 to 5, and they're saying now calculate the values of 2, 4 and 3, 5, which you can do. So this was the test case. Now let's see, using a bigger test case, how actually we are going to form the solution for this particular question. Let's see for this particular test case. This is x and y is given to me. Okay, so if we just sum it out, it will be nothing but -1, -3 is -4, and 2 is nothing but -2. Okay, now we have many possibilities for choosing L and R. So which one should we select? Now if we want the maximum possible sum, okay, whichever R we are selecting, okay, it should give the maximum possible value. It should give the maximum possible value. Now for example, if we select this R, okay, now what the value it will give, what the sum it will give from this L? So -2 plus 3 minus 1. Okay, so it will give 3 minus 1, that is 2 as a value. If we select this R, it will give effectively 2 as a value which will be added to our inner sum, correct? But if we select this R, this will provide me with a value of 3 plus 2 5 minus 1 4. Okay, so in minus 2 4 will be added, so it will be giving me the answer as 2. So in this particular case, which R we need to select, that will give me the maximum possible value. Okay, that R we need to select, that will give me the maximum possible sum between the range of y plus 1 to n. So between the range of y plus 1 to n, the index which is giving me the maximum possible sum, that will be nothing but R. Okay, understood this much? Similarly, if we go to the left hand side, to the L side, now if we select this L, so it will just give me 2 as a value to add inside of it. If we select this L, it will give me 2 plus 1 3 as the value to add inside, and if we select this L, it will give me 5 as the value to add inside. So that means I am going to select this L, okay, and this particular R. That will give me the maximum possible value of the sum. Fine. So in right hand side also we are going to select an index that is going to give me the maximum possible sum. In the left hand side also we are going to select an index that is going to give me the maximum possible sum. Okay, if it is not possible to get the maximum possible sum, or the maximum possible sum is negative, that will hamper the case, then we will simply go to L here and R here if we are getting negative values. Okay, such that in case of minus 1, minus 2, we will simply select L this, because even if we select any of this L, okay, it will just reduce our sum, not increase our sum. Okay, so in this particular case, how we are going to select the values? So as you can see, if an array is given to me 3 minus 1 and 2 at any particular index, what is the sum till now? How we find it out? It is find out using the prefix sum approach. So it is nothing but 3, 2 and 4. So at this index, what is the maximum value we get in the range of 0 to 2 is nothing but 4. So this will be selected as our R here. In the range of 7 to 9, the maximum value we get will be 4. That will be selected. Similarly here, if we have the suffix array, because it is going in the reverse direction, therefore I am calling it as a suffix array. So 2 plus 1, it is 2, 2 plus 1 is 3, and 3 plus 2 is 5. So what is the maximum value? 5. In the range of 1 to 3, that means from 1 to x minus 1. From 1 to x minus 1, in this range, the maximum value that I am getting is nothing but 5. Okay, and this is the help of suffix tree. And this value we are getting with the help of suffix array. So from y plus 1 to n, we need to create prefix array. Okay, and from this value we are going to create our suffix array. Fine. Now what do we need? Now another thing that we need is, we need to find out the maximum possible value in this and this, okay, in any given range, because it can be any given range. Okay, so we need to perform some range queries. Okay, we can be given any x and y value. And we need to find the sum between those x and y value that will be present here. After that, we need to find an R value that will give me the maximum possible sum, correct? And that we do not know what will be its range, correct? And here also we do not know L values, what will be its range. Okay, because we can select any value between 1 to x minus 1, and here we have to select any value between y plus 1 to n. So how do we perform these all operations? Let's see that. Since we are going to have q number of range queries, and also what we will be having the update queries as well. Okay, so we need a data structure that handles the range queries and update queries well. So for this question, we will therefore be using the segment trees. Okay, now using segment trees, what we can do is, given any number of range, that means given x and y as a range, I can simply find out the sum of x and y directly, correct? So in this case, the segment trees is very useful. So we will need a segment tree sum query. Okay, some segment trees that will give me the maximum sum in a range. Fine. Also, definitely we will need a prefix segment tree and a suffix segment tree. So whenever a query comes, we need to find out the sum, we need to find out the maximum possible prefix in that range, we need to find out the maximum possible suffix in the given range, according to the values of x and y. Okay, and then sum all these values and that will be the answer. Okay, so but how we are going to create? Okay, there is no need to create 3 segment trees. Okay, it is also a possibility. We can do this using a single segment tree by changing the node structure. Okay, instead of just having one single value, the node will have 3 values. That is nothing but the sum, the prefix and the suffix. Each node will have 3 values: sum, prefix and suffix. Okay, so let me just show you how a segment tree is built. Obviously segment tree knowledge is necessary in this. So how a segment tree is built, first step. Now once a segment tree is built and you know how the segment tree works, it will be easier for you to just simply do the update operation and the range query operation. Now the range queries will have no overlap, total overlap and the partial overlap cases. So I suggest you just learn about the segment trees for this particular video. Okay, so because the build operation I'm going to explain you, and I'm going to show you the codes for the range and update query operations, which are almost similar to the build operation. The same concepts are used, but obviously in the range query there are 3 cases and you should know about those 3 cases. Fine, so let's now see how a segment tree is built for the particular test case. Let's create a segment tree for this particular test case that is given in the bottom. Okay, and the creation of segment trees take order of n time. The query operation take log n time and the update operation also take log n time. Therefore for this particular question it is a perfect data structure. Fine, so first a 2 node, -1 node that we have 2 and -1. Fine, now we are creating a sum tree. So what is the sum between the range of 0 and 1? What is the sum between the range of 0 and 1? So this is 0 and this is 1. What is the sum? 2 minus 1, that is nothing but 1. So between the range of 0 and 1, the sum is nothing but 1. That is shown by this particular node. Fine. Now we have a node 2. Okay. Now what is the sum between the range of 0 and 2? Okay, that will be nothing but 2 plus 1, which is nothing but 3. So as you can see, 2 plus 2, 4, minus 1 is 3. Now between -3 and 3, what is the range? What is the sum between the range of 4 and 5? It is nothing but 0. And what is the sum now between the range from 0 to 5? 0 to 5 has the sum nothing but 3 plus 0, that is 0. So the upper node represents from 0 to 4. Okay, sorry, it is 0, 1, 2, 3 and 4. So from 0 to 4, the sum is nothing but 3. If you add everything, the sum is nothing but 3. From 0 to 2, the sum is nothing but 3. From 3 to 4, the sum is nothing but 0. Okay, from 0 to 1, the sum is 1. From 2 to 2, the sum is 2. So these are the ranges. And these are the indexes that in our segment tree array. These are the indexes in our segment tree array. Fine. So the first one will be nothing but representing 0 is nothing but the parent of 1 and 2, and it will be representing nothing but the whole segment tree sum. Fine. Now how do we get the sum? Suppose in the range of 2 to 4, it is not directly given in the range of 2 to 4. For that you should know about the segment trees, about the total overlap, partial overlap and no overlap cases. That is a complete different topic. Okay, so for this particular question you should know about it. Now this is how a sum tree is created. For this particular test case, a sum tree is created. Now let's create from this a prefix tree. With the help of this only, in these nodes only, we will also store with some values the prefix values. Okay, the maximum possible prefixes we will be storing. The maximum possible prefixes in a range we will be storing in this particular tree. Fine, let's begin. So the test case was 2 minus 1, 2 minus 3 and 3. Okay, the ranges are 0, 1, 2, 3, 4. So we have seen this is 0, 0 range. In the range of 0, 0, the sum is 2 and the prefix is obviously 2. In the range of that we have 1, 1, sum is -1 here and the prefix is also -1. Now in the range of 0, 1, which is the maximum prefix we get. In the range of 0, 1, which is the maximum prefix, is it 2 minus 1, which is nothing but 1, or is it 2? Because let's see, the maximum prefix in the range of 0 and 1 is nothing but 2 right here. This is the sum value that we have already calculated, and these are the new prefix values. So maximum prefix between 2 and -1, which is maximum, the maximum prefix that we are getting is nothing but 2 in the range of 0 and 1. Now let's see for this. In the range of 2, 2, the sum is 2 and the prefix is obviously 2 only. because this is just a single element range. Now in the range of 0, 2, what is the prefix? Now listen to this very carefully. In the range of 0, 2, what is the maximum prefix? Okay, so now 2 minus 1 plus 2 will give me the value as 4. Okay, so in this particular case, there are two cases which were here also, but here I have not explained. I am explaining it right here. The cases that are present here are the parent that we will be getting, okay, its prefix sum, either it will be the maximum of the left child prefix sum that we have already calculated from 0 to 1, the maximum is nothing but 2, okay, or the sum of the left child 1 plus our new prefix, that is 2 plus 1, that is nothing but 3. Okay, so maximum of 2 and 3 is nothing but 3, so the value of the new prefix sum is 3. What we just did here is nothing but from 0 to 1 we already knew what was the sum and we already knew what was the maximum prefix. Okay, so this was the sum and this was the maximum prefix. Now a new value came. Now either this value, that is nothing but current maximum prefix, will be the answer, or we will be adding our new prefix with the already present sum that we have, that is 2 plus 1, that is nothing but 3. So the prefix of 2 minus 1 and 2, the maximum prefix between the range of 0 and 2 is nothing but 3. Similar thing has happened here. In this also, how we got 2? Either it is the maximum of the left subchild prefix, that is nothing but 2, or it is maximum between the sum of the left subchild and the prefix of the second right tree. Okay, so it is 2 minus 1, 1. So which is the maximum? 2 was the maximum, therefore 2 was written here. Okay, so what is the line? It is a maximum between the left child prefix sum or the left child sum that we have calculated plus the right child prefix sum. Okay, so this is whole code. Now using this only, the whole prefix tree is created. Okay, let me just rub everything out. So the tree we will get is nothing but this for every range. Okay, so these are the ranges. In these particular ranges, know the maximum sum, the sum that we are getting, and the maximum prefix in that particular range. These two things we got. So let me just write this point down on one note also, so that it will be very clear how the prefix is created. And similarly we are going to create the suffix tree also. Okay, the next thing is suffix. In this node only, now we have the sum, we have the maximum prefix, then we will be having our maximum suffix. So this is the case that we are having. Correct. So the parent's prefix sum is maximum of left child prefix sum that I have already calculated, or the left child sum which we have already calculated plus right child prefix sum which we already have. So all these values are there, we just have to choose the maximum one. Similarly, to select for the suffix, so parent's suffix sum is also the same, maximum of right child suffix sum or the right child sum plus left child suffix sum. Fine. Why here the left child and right child are created? Because suffix is created from right to left. Okay, so therefore these two have inverted their positions and nothing else. So this was the how we are going to build the segment tree. Now if we just see here for the suffix, this will be the tree, how the tree will be formed step by step. Okay, so now for each and every range we have our sum. This is the final segment tree that will be created. For each and every range we have our sum, we have the maximum prefix, and we have the maximum suffix. Now all we need to do is take all the queries one by one, the x and y values, get the sum between x and y. Okay, then get the maximum prefix in the range of y plus 1 to n, and get the maximum suffix in the range of 0, in the range of 1 to x minus 1. It is in the base of 1 base indexing, and we can use the 0 base indexing as well. Okay, so we will get all these particular values. Now obviously these are the queries. Now for the queries, how the queries are calculated, you should know that. And this tree is built. Now how the queries are calculated is directly related to this. Okay, now after this we have an update operation as well. Now if you know about normal segment trees, how an update operation is done, similarly we are going to perform the update operation in this particular segment tree also. Okay, if a value at a particular index is changed, then what its effect will have in the whole segment tree, it will be propagated. I just wanted to explain you about the build segment tree. Now the update segment tree and the range segment tree, I will show you the code, and in that I will be explaining those points. So what is the logic of this particular question is nothing but rightly given here. Given any x and y in the segment tree, find the sum, then find the maximum prefix in this range, find the maximum suffix in this range, add all the values, and we are done. Okay, let me just show you the code. Okay, so in this, n equals to sc.nextInt. Okay, then the size of a segment tree is 4 into n in the worst case, so we are doing that. The segment tree is now initialized. It will have three values, 0, 1 and 2. That means 0 is for the sum, 1 is for the suffix prefix sum, and the 2 is for the suffix sum. Okay, then the query is taken as input, the array is taken as input, and the build segment tree function is called. Now using the build segment tree function, a segment tree is created. Okay, this is a recursion call. This is a recursive program. And this is a standard recursive program. Only the change we have here is nothing but in these three lines, and the upper ones are same, almost same. Okay, except this, because we need to update three values, therefore these are the changes. Now this is the exact same thing. To find the sum, it is nothing but the sum of the left subchild and the sum of the right subchild. So this is the, in binary tree we have the left into 2 into position plus 1, and the right is 2 into position plus 2. Fine. Then we need to select the maximum of the left child's sum, left child's prefix sum, or the left child's sum plus right child's prefix sum. So that is what we are doing here. Okay, right here. Now for the suffix part, maximum of the right child's suffix sum or the right child's sum and the left child's suffix sum. Okay, so this is how this whole tree is created, which I have just explained. Now after this line, what we do, we just have the queries one by one. Okay, if it is q, we take the values of l and r, we convert it into zero based indexing, call the sum query function. This is nothing but three functions, that is sum query, prefix query, and suffix query. In the sum query, we go and just calculate our sum query. This is for the no overlap, this is for total overlap, and this is for the partial overlap cases. Okay, in this we simply return the sum of the left and the right child. After this we have the prefix query, same, the three cases of no overlap, total overlap, and partial overlap. Now in this case, thus it is same as that as we have done. Okay, so the first p1 is calculated, it is nothing but the left child. Then the p2 is calculated, it is nothing but the right child, and the sum is calculated of the low to mid. Fine, that is of the left child. Now either it will be left plus right, or it will be only left maximum, as we have just seen above. The same thing, this one. Okay, similarly for the suffix tree, it will be three cases of total, no, and partial overlaps. We will calculate the s1 of the left child, the s2 suffix of the right child. Okay, and after that a sum and the maximum between that we have just seen above. Okay, now in the update query function, update segment tree. So in the update segment tree also we do this. So for this, obviously you should know about the segment trees. Okay, in this one also all the three values should be updated accordingly. Accordingly we have to propagate all the updates. So therefore the same three lines that are written above are written here, and the update segment tree takes care of the updating the values inside segment trees. See here. Fine. And when these values are assigned, the recursion will take care of propagating it throughout the segment tree, and these three lines we have already seen. So this is the code for this particular question. Fine. So this was the fourth question in the March CookOff. Thank you.